Zelda.
And I'm Christopher Komba.
We are going to introduce the automatic smart dustbin. The automatic smart dustbin helps to minimize the spreading of germs causing diseases. Because in the modern world, where hygiene and automation are becoming increasingly important, smart systems are adapted to improve health, convenience, and environmental care.
An automatic smart dustbin is an innovative solution designed to promote waste disposal, minimizing spreading of germs, and making waste management more efficient and hygienic.
This project utilizes the Arduino Uno ultrasonic sensor and the servo motor to create a smart dustbin, which automatically opens the lid when it detects an object, either trash or hand, approaching within a specified distance. Once the object is removed from the ultrasonic sensor or the smart dustbin, the lid closes automatically. This makes the users do not physically interact with the dustbin.
The understanding about the ultrasonic sensor. An ultrasonic sensor is a device that measures distance using sound waves. The ultrasonic sensor sends out ultrasonic pulses above human hearing 40 kHz. These pulses travel through the air, bounces off the nearest object and returns to the sensor. The sensor measures the time taken for the distance to return. In an automatic smart dustbin, the ultrasonic sensor is used for detecting someone places the trash or their hand closer to the bin. If the object is within 20 cm, the Arduino opens the lid using the servo motor.
In addition to that, the trigger pin is set for 10 microseconds to start the measurement. If it receives a high signal, it sends a burst of 8 ultrasonic pulses in a 40 kHz frequency, which allows the sound waves to travel through the air. If they meet an object like a hand or trash in a range, they are reflected back to the sensor to be interpreted to the Arduino through the echo pin. The echo pin measures the time the sound waves have used to go there and back through the duration of echo pin height.
Arduino Uno is a microcontroller board based on that Mega 382P chip. It executes program uploaded via USB, meaning universal serial bus. It has pins which inputs and control outputs. The role of Arduino Uno in this project: controlling monitor data from the ultrasonic sensor, decides when the lid should open or close, and also controlling the servo motor. How Arduino Uno works in this project: sensor sends object distance and Arduino Uno compares it with threshold. Why Arduino Uno is ideal for this project: open source, real-time response, and powered with moderate support.
And the interactions are: it emits sound and listen for the echo. The Arduino Uno does all it takes for the echo to enter the sensor. How it makes its decisions. In 20 cm, the Arduino Uno opens the sensor to the servo motor. This is the motor 90 degrees to lifting the lid. For short example, 2 seconds, the Arduino Uno closes the lid.
To answer the question, the servo motor is a rotational actuator used for precise control of angular position. In our dustbin project, the servo is responsible for opening and closing the bin lid by rotating to a certain angle when triggered by the ultrasonic sensor. We're using a micro servo motor such as the SG90, which is lightweight, affordable, and perfect for small DIY projects.
Servo connections to Arduino. VCC connects to 5 volts on Arduino and the function is passed on the servo motor. GND connects to GND on Arduino and the function is common ground. Signal connects to the 11 on Arduino and the function is receives PWM control signals.
We are using a servo motor. Unlike a normal DC motor that spins continuously, a servo motor only moves to a certain angle, which is ideal for lifting the lid from 0 to 90 degrees, returning to its original position, and holding its position without constant power.
Step by step in working the project. Step 1, idle state. The servo motor is at 0-degree angle and the lid is closed. Step 2, objects detected by the ultrasonic sensor. The ultrasonic sensor detects that the object, like a hand, is closer than 20 cm. The Arduino sends a PWM signal to the servo motor to rotate to 90 degrees. Step 3, lid opens. The motor shaft rotates to 90 degrees and the lid is in upward position. Step 4, wait for delay. The Arduino delays for 2 seconds in order to allow time for the trash to be thrown. Step 5, lid closes. The Arduino sends a new signal and the motor shaft rotates back to 0 degrees.
We did the Arduino programming.
Here is how we did this.
We used libraries and constants which included the servo library, which help us control the servo motor easily. A servo motor is a motor that rotates to a specific degree between 0 and 180 degrees.
In this component of library and constants, we use different accessories, including the trigger pin. I'll answer the question, what is a trigger pin? Trigger pin is the pin that sends out an ultrasonic pulse. Echo pin. I'll answer the question, what is an echo pin? An echo pin is a pin that receives the reflected pulse. Then there is a servo pin. I'll answer the question, what is a servo pin? It's the pin that is connected to the servo signal wire. Lastly, we have the max distance. I'll answer the question, what is a max distance? The max distance is the threshold distance in centimeter. If an object is closer than 20 centimeter, the servo will open the object.
Then we had to create a servo object named Servo in order to control the servo motor using servo.write later in the code.
Next up, we had a system function. What happens here? The serial begin 9600, that's the serial monitor for debugging. It allows you to see the distance in centimeter on your computer. Then we have the pin mode. The pin mode sets the trigger pin as an output while the echo pin as an input for the ultrasonic pulse. Lastly, we have the servo attach. The servo attach attaches the servo to the defined pin 11 so as we can control it.
Then there was a loop function. This runs continuously. We first trigger the ultrasonic sensor, which sends a 10 microsecond pulse from the trigger pulse. Then the sensor waits for the reflected pulse on the echo pin.
Secondly, we had to read the echo and calculate the distance. In this, there's a pulse. In the pulse, it measures how long does the echo pin stays high in microseconds. Then we need to divide it by 2 because it goes to and back from the object. Lastly, we need to divide it by 29.1 in order to convert time into distance in centimeter. The speed here is going to be 343 meters per second.
This is how we powered automatic smart dustbin. To rotate the motor, we needed a powerful rechargeable battery with more than 9 volts to 12 volts, and the one that we use is a rechargeable seed-lead acid battery that powers Arduino and rotate the servo motor and help the ultrasonic sensor to detect the trash.
My name is Joseph. As a mathematics expert, in this project, we guided the pupils to analyzing and calculating angles using the key fundamental programming and input the code through USB into the Arduino Uno. The importance of these calculations help to make prediction of both projects, especially in the automatic gate system and automatic smart dustbin.
Projects such as automatic dustbin, automatic gate opening system, and radar devices serve as perfect example of how classroom learning can be transformed into practical innovation, guiding pupils in designing and construction of these devices carries this significant importance.
As we approach toward the end of our spectacular presentation, let's hear some few words from the head of the school. Honorable Sister Leonora, why did the school decide to guide pupils in creating such projects?
We wanted our pupils to experience learning beyond textbooks. The projects address real-life needs. For example, an automatic dustbin promotes hygiene, a radar system teaches object detection technology, and an automatic gate improves safety. By building them, pupils learn to solve problems that matter in their daily lives and in our community.